Everything looks so clear. Everything looks brown. Everything is clear but brown. What's happening? Same eyes, different frame of reference. So what's happening? I chose these anti-glare glasses. It was all clear. But when I used this, it has got a tinge of color to it. Okay, so today we'll be talking about these frame of reference and there are various examples through which I can explain this frame of reference thing to you. In physics, it is important because you have to solve the question in one frame of reference. And you need to know the relationship between... So before we start solving this problem, so one thing that you should know by now is velocity of one thing with respect to the other thing is equal to velocity of one thing with respect to the common frame of reference minus the velocity of the second thing with respect to the common frame of reference. So before we proceed, let me give you another example. What's this? It's a glass of water. Some of you will be saying that this is half full of water and others may say that it's half empty. Optimistic and pessimistic. But I say that this is completely full, half with water and half with your attitude. Okay, another example, I saw some comments on my videos and somebody wrote that her lectures are so boring, and the other comment was, I love the way you teach. Same Pooja, same way of teaching, but two different comments. Their frame of reference. Different people, different frame of reference. Well, I deleted the first comment because he did his job, I did mine. I just love myself. I'm completely in love with myself. And if at all the need be, I'm myself sufficient to criticize myself and I do not need you to criticize me. I simply do not need such people around me. Get out of my life, out, like right now. Now, do you watch South Indian movies? Those unrealistic stunts, do they blow your mind away? Now, if I ask you to stand on a moving truck and watch me.
Watch me turn this life into something that you could never own. I feel this pain.
Sorry, jokes apart. Now this is a South Indian movie and you are the hero. Okay, you are a South Indian actor and you are the hero of the movie. And if there is a hero, hero किसका बना? Heroine should be there. बाकी तो किसी की नज़रों में तुम कुछ हो नहीं. Now this hero has to impress the heroine's father, who is standing on the road with his relatives. The heroine's father is standing here. Some bold figure. He is watching this hero. All other relatives are standing here. Now this hero says, Uncle Ji, I want to marry your daughter. And Uncle Ji in attitude says that, बेटा कुछ करके दिखाओ फिर. बेटा क्या खास है तुम में? क्यों तुम्हारे अंदर ये विचार आया? कुछ अलग करके दिखाओ. हमारी बेटी बहुत अलग है, कुछ अलग सा करके दिखाओ. All relatives are watching. And this is hero. अब उसमें कुछ अलग होगा तो वो दिखाए. Suddenly he sees a truck that is moving with a constant velocity of 14.7 meters per second on a horizontal road. I don't know what comes to his mind. He jumps into the truck, and now this hero is standing on the moving truck. And now the South Indian hero is standing on this truck that is moving with a constant velocity of 14.7 meters per second. Style. Do not try this at home. Okay, so I have a truck. So this is my truck moving with a constant speed of 14.7 meters per second, and the hero is standing here and some friends are sitting here. So this is the straight road on which this truck is moving with a constant velocity of 14.7 meters per second. Now while he is standing on this moving truck, he shouts like, "Uncle Ji, देखो अब मैं क्या करता हूँ." Now this hero is having a ball. Now this man throws the ball in such a way that this ball returns to the truck after the truck has moved a distance of 58.8 meters. And Uncle Ji is like, and the other relatives. Now this hero is having a ball that he has thrown at some angle, say theta, and it so happens that after this truck has moved some distance, after this truck has moved a distance of 58.8 meters, this ball again returns to this truck, and this fellow out here catches the ball. So this can be the trajectory. Trajectory is the path that will be followed by this ball. And the hero, heroine is like, now this uncle is still not satisfied. He says, "Beta, ये सब circus तो ठीक है." He wants his son-in-law to be intellectual as well. बेटा हमारी बेटी पढ़ी लिखी है. So he says, "बेटा ये सब circus तो ठीक है, but can you find the speed and the angle of projection with the help of which you have done this drama over here?" Now this hero is again like, तो बढ़ते ही जा रहा है. And the relatives. So this hero asks his friend, who is also standing on this moving truck, कि भाई क्या थी speed और angle of projection? And his friend says, भाई सीधा गया, सीधा, एकदम सीधा गया. बोल दे. भाई speed का तो पता नहीं, एकदम सीधा गया, एकदम सटीक ऊपर, सटीक सीधा ऊपर. And this hero says, "अंकल जी बिल्कुल सीधा मारे हैं, एंगल ऑफ प्रोजेक्शन 90 डिग्रीज. स्पीड अभी कुछ दिन में बता देंगे, बट गया सीधा ऊपर है 90 डिग्रीज." But uncle ji and relatives are still not satisfied. They are standing on the ground and they are saying that बेटा हमें तो कुछ टेढ़ा सा लगा, ठीक से तो हम भी नहीं बता सकते, बट किसी तो एंगल पे गिरा है तुमने, बेटा बिल्कुल सीधा तो नहीं गया. Now this hero is like, heroine is nowhere. Heroine to has left. She is nowhere in the picture. She is like, so you have to solve this situation. Now you have to help this hero. Please help him and find out. You have to find out the speed and the angle of projection as seen from the truck and as seen from the road. So okay, let us help this person to find out the solution to the problem. So now what you have to find is, so let us suppose this angle of projection is theta and the velocity. This ball has to be thrown with some initial velocity, say u, so that after the truck has traveled some distance, this ball again returns to the truck. So let us assume that initial velocity is u and the angle of projection is theta, and these are the two things that you have to find in the problem. First of all, as seen from this road and as seen from this truck, as observed by these friends from the truck. So the situation in which your hero is this. I hope this is clear. Now, if this one happens to be the ball and this two happens to be this truck, and the common frame of reference is the ground or the road on which these people are standing. So this can be the ground. So velocity of ball with respect to the truck equals to velocity of ball with respect to ground minus velocity of truck with respect to ground. Now this 14.7 meters per second is the velocity of this truck as seen by these people standing on the ground. So this 14.7 is this velocity of the truck with respect to the ground. Now we have two things here, velocity of ball with respect to the truck and velocity of ball with respect to the ground. And these are also the two frames of reference. Two different frames of reference. One is attached to the road or the ground and the other is attached to this truck. Now let us first focus on the results that we will be obtaining as seen from this Uncle Ji and his relatives. Uncle Ji is more important. ये सब तो मान ही जाएंगे. So the first thing, you know, the acceleration of the truck is 0. So for this 0 acceleration, you will be applying the kinematic equation of rectilinear motion in a straight line with constant acceleration, and I will be using this equation. I know which of them to choose. So S is 58.8 meters, the initial velocity of the truck being 14.7 meters per second, and I need to find this time that this truck takes to move from here to here, and let that time be t. Acceleration is 0, so this term vanishes, and the time comes out to be 4 seconds. Okay, so now I know that this truck requires 4 seconds to reach from this position to this. That is, this truck requires 4 seconds to travel a distance of 58.8 meters on a straight road. And I know this ball has an angle of projection theta with which it is projected with the initial velocity of u. This ball follows a path like this, and the time of flight, and this time of flight happens to be 4 seconds. That is the time that this truck is taking to reach this position here, to reach this distance here. The time that this ball will take to reach the maximum height, that is, the maximum height is somewhere here, at which the final velocity will be 0. The ball reaches its maximum height, the velocity becomes 0, and thereafter it again follows a path and returns to the truck. This is what is happening. And taking into account the symmetry of such a path, this is the projectile motion, the time of flight will happen to be 2 seconds. Like 2 seconds from here to here and 2 from here to here. So the time this ball takes to reach this maximum height is 2 seconds, and at this height the velocity of the ball will be 0. So I will be applying another equation, that is v is equal to u plus at. The final velocity is equal to initial velocity plus acceleration into time. And now I will be choosing, I know I have x and y directions, I will be choosing and working with one direction at a time. So this happens to be x, this happens to be y. Let the component of the velocity u in the x direction be ux, and the component of the velocity in the y direction be uy. Okay, so I will be applying this equation to find out the velocity in the y direction. Okay, so this velocity in the y direction, so this final velocity will be 0 after 2 seconds, that is the time, and the initial velocity I do not know, let it be uy, and because of the gravitational pull of the earth, this acceleration due to gravity is minus 9.8 meters per second square in the downward direction, so this is minus 9.8. So this uy happens to be 19.6 meters per second. This uy, this is this. So I know this, so I will write it like 19.6 meters per second. We are working in the reference frame attached to the ground at the moment. Okay, so this is done. Now another thing is to find this ux. I know the initial velocity will be this. This will be the resultant of the velocities in the x and the y direction. I have obtained this. Now my aim is to obtain this. Now, as seen from the people standing on the ground, the velocity of this ball as seen from the ground is also 14.7 meters per second. How many of you agree to that? नहीं भी करोगे तो क्या हो जाएगा? यही है. Even if you do not agree, hardly matters, it is this value. Until and unless this stunt was performed, the ball was in the hands of this hero, and this hero was standing on the truck. And if at all they are watching all this happen, and if at all this ball is also visible to these uncle and aunties, the ball is also moving with the velocity of 14.7 meters per second in the horizontal, that is x direction, with a velocity of 14.7 meters per second, such that the velocity of ball with respect to the truck, is 0. This point should be clear. That means in the x direction, the velocity of the ball with respect to the ground is 14.7 meters per second. So I know this to be 14.7 meters per second. So now what is the resultant of these velocities? This is u, and you will be putting the values of this and this, squaring, adding and taking the under root. You will be getting your u as 24.5 meters per second. Next thing is to obtain the angle of projection, that is this theta. And you know that this theta, this tan theta, is uy divided by ux. And what are the values? Simply put them. And this happens to be 1.33, and theta is tan inverse 1.33, and this is approximately 53 degrees. So you have obtained the initial velocity and the angle of projection of this ball as observed by these fellows standing on the ground. जो इनको लग रहा था कि the ball was thrown at some angle, that angle was actually 53 degrees. Now we have to work in the reference frame attached to the truck, like what the situation will be when these two people out here, these friends of this hero, are observing the ball. What will be their point of view? So now we have to work in the reference frame attached to these friends. So one thing you already know is, when we talk about the velocities along the x direction, you have the velocity of ball with respect to the truck to be 0. And how this is 0, we have already discussed. So in the x direction, the initial velocity of ball with respect to this truck is 0. Now you have to work in the y direction. You have to work along the y direction now. And for the y direction, you will be again applying this v is equal to u plus at. So this final velocity is 0 after 2 seconds. So 0 is equal to uy, you do not know, and this is that very thing that you have to find. Acceleration due to gravity is minus 9.8 into 2, and uy again happens to be 19.6 meters per second. So what do we get here? As seen by his friends, the resultant velocity, that is u, will be under root of this velocity and this velocity. This is ux. Ux is 0. So this comes out to be 19.6 only, because there is no component of velocity along the horizontal direction as observed by these people who are themselves sitting inside this truck. So what will be theta in this case? That will be 90 degrees because you only have vertical component. And also if you find tan theta, that is uy over ux. You have only uy, ux being 0, so this comes out to be infinity. So tan theta is infinite at theta equal to 90 degrees. So both ways you can do this. So as seen from the truck, u is 19.6 meters per second and theta is 90 degrees. For the same situation, two different frame of reference, two different answers. So heroine was a physics student and she knew that both of them are correct in their own ways. Their frame of reference is different, but both of them have calculated or given the correct answer. दोनों ही सही हैं, but नज़रिया अलग है. So I hope you like this video, and if you do not forget to give it a big thumbs up. So I hope you like this video, and if you do not forget to give it a big thumbs up, and I'll be back with my next video. Till that time, do not forget to take really good care of yourselves. I'll be back with my next video.